Thank you. Hi, everyone. My name is Yambin. I'm really truly honored to be here. And today I'm going to run through two key topics. The first part of the sharing, I'm going to cover Wi-Fi 6 and how we can leverage from the Wi-Fi 6 solutions to meet today's challenging demand. The second part of it, I'm going to bring you on a sneak peek on the next generation Wi-Fi standards. It's called Wi-Fi 6E, and why we all should be excited about it. So sit back, and I hope that you enjoy today's sharing. Today, we are living in the world that is swamped by a lot of data. Data that I'm talking about is not the data generated in the cloud or the data center. Rather, we are talking about the data that is produced in high quantity at the edge. Within the next 2 years, it is projected to have more than 55 billion of devices connected worldwide. And there will be a lot of data coming from all these devices. So for example, if you and I are driving an autonomous car, there is a lot of data coming not just from the GPS to direct us to go from one place to another place, but there are a lot of sensors around the car so that the car can make an informed decisions to turn right, turn left, or make a stop. Hence, there's a need not only a new Wi-Fi standard, but more importantly, the new architectures that is simple, that is AI-driven, and help us to process this large amount of data, and at the same time reinforce with security to help us to keep the network and data protected. How is it okay right now?
Yes. Yeah,
okay.
It's showing now.
Sorry about that. Right. So as shared by my colleague just now, KH, Aruba ESP architecture is industry first AI-powered cloud-native platforms to help you to unify, to automate, and protect your network. And just to recap, this architecture uses AI, artificial intelligence, and machine learning in order for us to predict the issue and optimize the network before they impact the users. Today, I'm going to double-click on the unified instructions, more importantly on the Wi-Fi, and how Wi-Fi 6 can help us in this data-driven era. In the previous standard, we have Wi-Fi 5 and below. The protocol that we used to run is called OFDM. This is shown in the pictures on top. So what OFDM does is when the client is connected to the AP and the AP is sending the packet, the entire channel is usually dedicated for the clients. And the AP had to send the packet sequentially, packet by packet, to each client. If the packet size is very small, and you can see the truck is mostly empty. That's how OFDM works. However, at the bottom of the slides, you can see OFDMA, which is the secret sauce of Wi-Fi 6. In OFDMA, we can break down the channel, you can visualize as a route, into the sub-channels. As you can see from this picture, we can send 4 different packets to 4 different clients simultaneously without having to do it sequentially. So this helps us to reduce the latency. Another enhancement in this Wi-Fi 6 is this thing called MU-MIMO. MU-MIMO stands for multiple user, multiple input, and multiple output. It was created to support environments where they have a lot of multiple users trying to access the network at the same time. MU-MIMO helps to break down the available bandwidth into separate individual streams and share the connection equally to several people. In the simple term, if you imagine you are in a school canteen and you are queuing out to buy burger, however, there's only one lunch lady serving you and everyone in the queue. But with MU-MIMO, instead of having just one lunch lady, you can now have 2, 3, or even 4 lunch ladies, which help us to shorten the time to wait to get our burger. And there are a lot more other features in Wi-Fi 6. One other feature is target wait time. What target wait time does is it helps to negotiate the wake up and sleep time for individual devices. For example, when there is no packet or information to be shared from this mobile phone, we would then put them into a sleep mode in order to conserve battery life. This is particularly useful, especially when we have battery-powered IoT. At the same time, this helps us to reduce contentions as well as overlap between stations. With many new benefits of Wi-Fi 6, it's my pleasure to share with you Aruba has released the full portfolio of Wi-Fi 6, not just for indoor, outdoor, also recognized version. And this AP are Wi-Fi Alliance certified, which is really important to ensure interoperability with other Wi-Fi 6 clients. Besides that, this Aruba AP are certified with Passpoint for us to have seamless connectivity to 5G. At the same time, it's powered by WPA3 latest security protocol. And launch, we actually ship more than 2 million of this Wi-Fi 6 access points to more than 3,000 customers around the globe. Why customers choose us? Because we give them choices. We have customers who start off with a small setup. They have less than 20 AP per site. They can leverage on our cost-effective controllerless instant architectures, which provide the clustering technology. As our customers' business grow with the presence of multiple sites, they can then upgrade their management tool to cloud while having the same AP hardware, and which allow them to manage multiple networks in multiple locations without having to go on site. In addition, if the business grew even further, they need to enhance security with added firewall, as well as they need seamless roaming. A controller can be added to the network without ripping and replacing the existing network. This is the true benefit of deploying Aruba network, where customer can choose the architecture that is suitable for them and have the upgrade bar around down the road. Besides that, Aruba Solutions is also built with AirSlice feature. This AirSlice technology is 5G equivalence of applications assurance in Wi-Fi world. AirSlice is uniquely designed by Aruba. It is designed to optimize user and applications experience, leveraging on the different Wi-Fi 6 technology, such as OFDMA, target wait time, and MIMO, where IT can then guarantee the performance, especially when you have latency-sensitive applications such as Zoom that we are using right now, Slack, and many, many more. If your company is driving green initiative and has the need to cut down electrical bill, Aruba Green AP feature might be of your interest. For example, at 6 p.m. today in the evening, when most people will have gone home, and the network in the office would be underutilized. What this Green AP does, it would put the AP into the sleep mode whenever the network detects there is no client's connection at all. This will help to cut down the power consumptions of the AP in terms, and as a result, you will cut down the electrical bill. We have customers in US that save more than $100,000 each year by just turning on these Green AP features alone. And Aruba AP can serve as a platform for IoT connectivity. The reason that we can do that because we not only support wireless, we also support Bluetooth, we support Zigbee and USB. Without this IoT gateway functionality, what customers traditionally do is they have to run multiple networks concurrently to support these different IoT devices. This not only increased in terms of cost, but also added more complexity to the network. At the same time, the network operator will have a hard time monitoring all the activities of these IoT devices, as well as maintaining policy for them. Aruba, in partnership with Wi-Fi Alliance, has invented the latest security standard. It's called WPA3. This standard is designed to improve the security and protections and onboarding procedure for personal, public, as well as enterprise network. With WPA3, there is no longer an open network. That means all the wireless traffic is encrypted by default. This helps to maintain the security of the network. On top of that, Aruba has also announced a new offering, we call it Airpass. This helps us to bridge the 5G world, cellular world, as well as the Wi-Fi world. What Airpass does is let the enterprise as well as the service provider to provide a seamless handoff from a 5G network to wireless network for voice and data. The goal is to provide a seamless user experience and maintain high quality of service to the users. This is important, especially for indoor. The penetrations of 5G will be poor because it does not propagate very well through the wall. So what PassPoint does is automate in terms of authentications between the carrier as well as the wireless network. That means if you would like to use it, you do not need to go and choose a network or sign in with the credentials or go through any portals. You can seamlessly upload into the Wi-Fi. So user can make voice call, they can send text, and they get data access automatically through on the Wi-Fi. So with this, I would like to bring you to a sneak peek to the future, which is WiFi6E. In April 2020 last year, when most of the countries are fighting COVID-19 pandemic, in US, FCC is making a landmark decisions to open up 6 GHz bands for unlicensed use, while many other countries are also exploring the adoptions of this band. Why is it important to have this 6 GHz band? 6 GHz actually unlock new applications as well as help us to make full use of equipment and capability that Wi-Fi already have. Because most of the customers are still running at 20 or 40 megahertz channel in the environment because there isn't enough spectrum in 5 gigahertz to use the wide channel. However, if you look into 6 gigahertz band, we have the ability then to turn on 80 or 160 megahertz by default because there are more bandwidth available, which is incredibly powerful to help us to unlock a huge range of different applications. Some applications can be the next generation's AR, VR, or at the same time, mission critical applications, for example, hospital imagery applications or high-speed tethering. And you can see from this graph, right, 6 gigahertz will increase the available spectrum for unlicensed operations by more than 3 times. So among 70 countries that are looking into this WiFi6E, 38 countries have already adopted, which is account to 1.2 billion of people. And the list of countries are posted on Wi-Fi Alliance website, which you can actually check it out to understand when is Philippines going to open. Some of the benefits of WiFi6E is they are more than double the capacity in terms of meeting the demand. And you have a lot more wider channels to support high bandwidth, low latency use cases such as high definition videos and AR. And you have less interference because the number of Wi-Fi6E enabled devices is much fewer as compared to in 5 gig and 2.4 gig. And you also provide a complementary solutions for low cost, high speed capability in high density area. So let's look at the map, right? 6 gigahertz band map. That is a total of 1200 megahertz channel that is available. However, some countries have approved to use the full 1200 megahertz spectrum, like US and some of the APJ countries, like Korea and etc. But some countries like Europe are only adopting the lower 500 megahertz channel. In APJ, South Korea has started adopting WiFi6E. Other countries like Japan, India, South Pac, Thailand, Taiwan are in consultation phase. However, we believe that WiFi6E will move really, really fast, and it will be a matter of time when all countries will start adopting WiFi6E. So some of the questions that we really get, how Wi-Fi 6E complement with 5G. Actually, they are incredibly complementary. Many of the 5G use cases does include Wi-Fi. For example, if I'm having a phone that supports 5G today, I use the phone as a tethering options to my probably AR or VR goggles, and it is paired with this very high bandwidth multi-gig 5G connections. But however, from the phones to the goggle is through Wi-Fi. Similarly, if you look at autonomous car with 5G connections, the internal of the car, the communication, we typically use Wi-Fi. So we can see from this graph, 5G and Wi-Fi actually works together in order to realize the end-to-end benefit and value proposition. So in Wi-Fi 6E is slightly different in terms of the type of AP and the type of clients. There are totally 3 different types of AP and 3 different types of clients. The reasons we have so many different types of AP and clients because they are a set of incumbents that we are sharing this 6 gigahertz spectrum with. They have been using this band for many, many decades. And one of the most heavily deployed bands for point-to-point microwave services. And the design has to be done such a way we protect all this incumbent. The first solution is low power indoor. This low power indoor is really restricted for indoor applications. And the devices are limited by the rule of going outside. They're also limited by their form factors. So since they can only be deployed indoor, they cannot be weatherproof. They have to be connected to the main power most of the time. So another type of solution is standard power AP. They are typically fixed, but they have this standard power means the ability for them to use a higher power as compared to the lower power. And these devices are typically outdoor, but they have to be controlled by a spectrum database called AFC, Automatic Frequency Coordination. So in order for this AFC to be effective, it needs to know where is the locations of this AP, outdoor AP in different parts of the world. As a result, this device has to be able to have the self-locating functionality. That means it has to have embedded GPS in it. And the last category is this low power AP, very low power AP. This is Wi-Fi for moving vehicles or tethering, for example. In US, they has not permitted this very low power AP operations. However, in EU countries, they are looking to embrace this. So depending on the country, you may have, may or may not have such solutions available for your country. And in terms of client devices, there are also 3 different types. In order to protect the incumbent, there has to be 4 times less power than the AP. Let's say your standard power AP are powered at 4 watt. The clients have to be kept at 1 watt. If you don't want to take the power hit, you know that you will be indoor, and FCC allowed this subordinate indoor devices. Just like any indoor devices, it has to be connected to the power most of the time, and it cannot have any antenna connected. And last but not the least, we have also outdoor equivalent, which is for the fixed devices. This is used for point to multi-point mesh deployments. For example, you are in education, you will probably have temporary classroom that's spread around the main building, and you want to have a central radio that distributing all these connections out to this temporary classroom. That's where you can use these outdoor client devices. So yeah, I know it's a bit, a lot too much technical, but more importantly for us here is how do we prepare for Wi-Fi 6E? One of the major changes that will be, which is switching port, because both data rate and power over Ethernet budget will definitely go up. If you look at Wi-Fi 6, if you are having 2x2, probably one at 2.4 and the other one at 5 gigahertz, you will not exceed 1 gigabit per second throughput. This is the reason why many people has not upgraded their switch. However, as we move towards 6 gigahertz, this has changed. If you look at this chart, at 2x2 special streams at 80 megahertz, you are already running at 1.2 gigabits per second. If you are running at 160 megahertz, you will be running at 2.4 gigabits per second. And this excludes the fact that you have to aggregate the performance from the other two channels, which is 2.4 and 5 gigahertz. That means also you need to deploy at least 2.5 gigahertz or 5 gigahertz smart rate switches for every WiFi6 AP that you deploy. On the other hand, when you talk about PoE budget, if you have 2x2 special streams, 3-band, and you might get away with PoE power that is less than 30 watt. However, if you want to go 4x4, 8x8 special stream, the power consumption will be greater than 30 watt. And that is where you need to start looking to switches that are capable of providing BT PoE power. With that, it is my pleasure to introduce to you Aruba AP635. This AP supports Wi-Fi 6E, and it has triple radios in it that support up to 3.9 gigabits per second aggregate throughput. This solution allows us to use 7 of this ultra-wide channel 160 megahertz. Some of the key value propositions for this AP, including this tri-band coverage, because it has 3 dedicated radios that built in this platform. And on top of that, there is this ultra tri-band filtering to enable you to operate 5 gigahertz and 6 gigahertz operations simultaneously. And we also have high performance wired connectivities, and it has dual Ethernet smart rate support that support 2.5 gigabits per second each, and to provide you the power as well as Ethernet resiliency. And this AP also serves as a platform for your IoT connectivity because it has Bluetooth, it has Zigbee, and it has USB support. And most importantly, this product supports automated update of regulatory rules, especially when the whole world are in the ongoing process to roll out Wi-Fi 6E. What does this mean? It means that even though 6 gigahertz may not be open for your country in Philippines right now today, you can still purchase this AP and upgrade the software whenever Philippines has adopted Wi-Fi 6E. So this allows you to buy and future-proof your network with the solutions that provide you 3 times more bandwidth available. As you understand, typically upgrade of any network usually come once every 3 and 5 years. You definitely wanted to get your network ready for this coming Wi-Fi 6E. And we also expect to see rapid adoptions where countries are looking to open up the spectrum. Within the short span of 1 year, we already have 38 countries adopting Wi-Fi 6E, and we have 32 more countries on the way. Just now, I spoke about this ultra tri-band filtering, which is built in this platform. Why is it important? This is important, especially if you are running in higher band of the 5 gigahertz channels and also lower band of these 6 gigahertz channels. As you can see, the separations between these two are approximately 50 megahertz channel. Right? If you are running both at the same time, what user will experience is performance degradations due to the signal interference between these two bands. And the normal filter you will get out there is how do they protect this channel? They chop off some of the channel on both sides, right? So at the end, you might use up approximately 8 channels to be used. But however, in Aruba, we have this built-in ultra tri-band filtering, which we are having the patents that is pending. Is much more sophisticated because it includes filter that dynamically switch in and out depending on which channels you are used. So the net result that you will get is you can have simultaneous use of highest 5 gigahertz as well as the lowest 6 gigahertz functionality with minimal budget. So just want to share with you, this is the test done on actual AP635. With this ultra triband filtering that we built in, we are able to operate both upper band of 5 GHz and the lower band of the 6 GHz simultaneously. And you can see they achieve almost the light speed. And when you total up the aggregate data rate, we can pump up to 2.2 gigabit per second in actual test environment. So how do we expect to deploy Wi-Fi 6E? Do we need to pull out more cables? Do we need to increase the density or the ASP? From our study, you would deploy 6 GHz network just like how you deploy 5 GHz network. The signal coverage for 5 GHz network and 6 GHz network is almost similar. What we believe most customers will be deploying is they will have some AP running on the 2.4 GHz on adopting 20 MHz channel. This is for existing devices that are still supporting only 2.4 GHz channel, and also we have IoT devices that running in at 2.4. And we will have 5 GHz radio that running on 5 GHz as well. That is mainly for mainstream high performance devices. And with the open up of this 6 GHz band, you can actually operate 5 GHz at 80 MHz channels. And also we will see a lot more devices coming up, not just handphone, laptops. There are more devices coming up to support 6 GHz. That's where you can deploy multiple 160 megahertz channel of 6 GHz band to support these newer devices. Some of the questions I do get, like, is there any other end devices that support 6 GHz today? The answer is yes. Samsung Galaxy S21 Ultra, as well as Xiaomi and some other the new end customers and clients are already supporting this Wi-Fi 6E today. Right, so in the nutshell, before I summarize, especially today, we see Wi-Fi is oversubscribed. There's so many different devices, be it smartphone, IoT, or many other devices that is, crowding this space, and it actually throttles the performance, and it negatively impact our user experience. It also reduce the productivities and put our digital initiative at risk. So Wi-Fi 6E is designed to add more bandwidth for Wi-Fi need. And today, more than 70 countries are looking to adopt Wi-Fi 6E. And Wi-Fi 6E offer investment protections, especially for you to access to this 6 GHz band. And Aruba AP solutions allow you to buy and purchase this AP first, and then turn on using software to turn on the 6 GHz whenever that's ready. So it will help you to future-proof the network with the latest solutions. So before I end the call, end these presentations, I would like to share with you some of the recognitions that we have received from the Gartner, the IDC, and Forrester's. And we are one and only vendors that have been rated as a leader by all these different analysts, and we are humble that we are receiving this recognition. So with that, I will pass the mic over back to the host. Thank you so much for your time.